Okay, use the calculator to sketch, or use the calculator to draw the plane curve, right? Because that's what the graph of parametric equations is. And they've got three examples here, right? X equals t squared, y equals t to the third is the first. Now, the easy part is put those equations, t squared and t to the third, here, right? The harder part is setting the window. It's not hard, but it's just you do have to think a little bit about how you're going to set the window. I think it's said in the problem, this is the part that I forgot to write, that make t between -4 and 4. So it did give us a domain statement. So go ahead and try to put this t squared and t to the third on those first two lines. So here you go, t squared and t to the third. Okay, and we've already been told to use -4 to 4 when you set the window for this. So definitely I've got it at -4 to 4 for t. But then how do you set the window for x and y? Well, you have to think about if you go from t equals -4 to t equals 4, what does that do in these two equations? I mean, for x equals t squared, because it's t squared, it's always going to be positive or 0, right? And so 0, if t is 0, then x is 0. What will be the biggest value that x can have? 16, right? Because if you plug in 4 or -4, you get that. That's why the x's go from 0 to 16. Just because I looked at the equations, it said it needs to be from 0 to 16. Same way for the y's, you know, that's got to go from t is -4, y is -64, t is +4, y is +64. So the window is -64 to 64 for y. So you got to think just a little bit before you set the window if you want it to look exactly the same. So I've already loaded this in, and the graph should look something like that. These are in the book too. You could compare it to that too. I'm not sure all of their scales are accurate. It looks like their graphs are accurate. Maybe they're used a different scale, or they've labeled it differently, maybe even incorrectly, but it should look like that.